The dtmc300 spectroradiometer has been removed from the EnviroBox for the purposes of explaining some of the features of this device. It is composed of the dtmc300 double monochromator, suitable detector, detection electronics, and for the characterization of radiometers, additional accessories. The dtmc300 monochromator is composed of two single 300mm focal length monochromators, rigidly fixed together and working in tandem to provide effectively a 600mm focal length double monochromator, since they're operated in additive dispersion mode. In each monochromator is fitted on a turret 2,400 groove per millimeter gratings, allowing measurements over the range 200 to 600 nanometers. Light entering the entrance slit of the monochromator is relayed through 45 degrees by a plane mirror to a spherical mirror of 300mm focal length. The distance between this mirror and the entrance slit is 300mm, and therefore light is collimated onto the diffraction grating. On the diffraction grating, firstly diffraction obtains and interference results, providing dispersion of light from the white to the wavelength contributions it contains. Light is then collected by a second spherical mirror and taken down to the middle slit via a plane mirror at 45 degrees. And light goes through the same process in the second monochromator before being sent to the photomultiplier. The bandwidth of the device is defined by the largest of the entrance and exit slits. There's two ways one can think of this. In the first instance, in the simple manner of thinking of it, is that light at the exit port has been dispersed. Effectively, we have a wavelength axis across the exit slit. It is clear that the wider the slit present, the more wavelengths are sampled at one time. At the entrance slit, this also has an impact on the bandwidth, and simply because this is an imaging optical system, at the exit slit one effectively has images of the entrance slit in all the component wavelengths. So by using a large entrance slit, one can have at the exit slit a large image. It follows that the largest of the two define the bandwidth, but we tend to use the same dimension entrance slit as exit slit. The middle slit should always be about 20% larger than the other slits, otherwise tracking problems may exist between the two monochromators. Slits are rectangular. The horizontal dimension defines the bandwidth. The vertical dimension is effectively a volume control, the amount of light that is transmitted by the system. The slits here are 20mm high. To remove slits, one should loosen the covers of the slit to remove the cover, and using pincers one can pull out the slit in question. One should be very careful when installing slits. They have a etched side and a flat side, and at all times for the entrance and exit slits the flat side should be against the monochromator. If we place it the wrong way around, then a wavelength error may result. So with the flat side against the monochromator, one simply pushes the slit down firmly before fitting the slit cover back in place. Before changing the slit in the photomultiplier exit port, one should switch off the high voltage supply to ensure we do not expose the photomultiplier to ambient. With regards to the middle slit, one must pay attention that the middle slit effectively belongs to the first monochromator. The rule regarding the orientation, the flat side against the monochromator pertains to the first monochromator. So for the middle slit, the flat side against the first monochromator, and one can push the slit in place. The system is supplied with slits to obtain 1, 2 and 5 nanometer bandwidths. At the exit slit of the radiometer mode is fitted a 1.5 by 5 millimeter aperture to ensure we underfill the radiometer under test. And at the exit slit, the mirror is based on a solenoid, a swing away mirror, and through the computer we can select to relay light to the photomultiplier or to the radiometer RSR unit. Behind the entrance slit is to be found an order sorting filter wheel. This 6-position wheel contains a shutter for the purposes of dark current measurements to allow no light to pass through the system. The first position is without filter, and the second position is fitted with an OS400 400 nanometer long pass filter. Inserted at 400 nanometers, it ensures higher orders are suppressed. For example, at 450 nanometers, second order 225 nanometers, which would occur at the same location, is suppressed. We can only measure the first order. The light is taken to the monochromator through a fiber in the case of the measurement of solar irradiance. There's an adapter plate for this purpose, or via the IL7 light source for the purposes of the characterization of radiometers. At the exit slit, we have, for the measurement of solar irradiance, a detector with a 45-degree mirror and a bialkali photomultiplier. This bialkali photomultiplier has a very, very high sensitivity and is very useful in the measurement of solar irradiance. It has a spectral range of use of 200 to 650 nanometers. The output from the bialkali photomultiplier is connected to a suite of transimpedance amplifiers in the detection electronics unit. It's connected to detector input 1 to a 6-decade transimpedance amplifier. The photomultiplier also requires a high voltage for operation, and this is provided by a high voltage output connected via a thick BNC cable to a labeled port, and there's a simple on-off switch to ensure the high voltage is on or off. There is an adjust port, but the high voltage has been set to 750 volts, minus 750 volts in factory, and this need not be changed. When using the system in the radiometer mode, the photocurrent from the reference and monitor diodes or the device under test through the 472 unit and the monitor diode will be connected to detector 1 and detector 2. There's a temperature sensor to monitor the ambient temperature in the EnviroBox, and there's another temperature sensor fitted to the frame at the front with a 3-pin connector which goes to the temperature controller of the EnviroBox. There's one mains inlet to the entire spectroradiometer with an on-off switch and a thermal cutout. There are 2 USB inputs, one to the detection electronics at the top and another to the rear to connect the monochromator to the USB interface.